Hi guys, welcome back. So in this video, we will continue to discuss renewable resource. And remember, in the last video, we talked about fisheries, and in this video, we will talk about forest and also timber, trees, all those kinds of stuff. So this figure shows the original forest cover on the earth, and the second figure shows the current forest cover on the earth, which is represented by the dark green area. So as we can see, the dark green area in the second graph is much less than the original forest cover, right? So what's going on? So for some part of the land, the forest was decreased because of humans' activity. For example, the dark brown area represents the area which was forest before, but now it is cropland. And the light brown area on this graph was covered by forest before, but now it is covered by pasture. And the red area which was covered by forest, but now the forest is missing due to tropical deforestation. So as we can see, the forest area is decreasing due to humans' activity. However, we also try our best to restore the forest. The light green area represents the walking forest landscapes. The effect of deforestation and forest degradation is much larger than we thought or than I expect. Those two account for 20% of global greenhouse gas emission, which is more than the entire transportation sector. So it is very important for us to take action to restore the forest. And what makes timber unique? What is the meaning for us to study forest, to study timber? First, timber is both an output and a capital good. The harvest decision involves how much timber to harvest, how often to harvest it, and whether to replant our harvesting. Standing trees are capital assets. Tree growth increases the harvestable volume, and standing trees provide watershed protection and wildlife habitat. However, there may be some externalities which make it difficult to make those decisions: how much to harvest, how often to harvest, and whether to replant after harvesting. So in this video, I will just do a brief introduction about how to make decisions, how to make the harvest decisions, and how to decide the rotation length of a forest. So first, let's see how trees grow. Tree growth is measured on a volume basis. Young tree will grow tall quickly, but volume growth is very low for young tree. Medium-aged tree increase in volume quite rapidly. Mature trees grow very slowly and eventually stop growing or reverse growth. Growth will also be affected by weather, soil, disease, forest fires, and human activity. So the graph on the right shows how trees grow. At first, when tree is young, the growth rate is very low, and the growth rate for medium-aged tree is much greater than the growth rate for young tree or for mature tree. So as we can see, we can get this curve for tree growth, and a total length for tree to be mature is 135 years. From biological management's perspective, they want to maximize average annual growth, and in other words, they want to maximize the total growth and the margin. And here we have two terms we need to make a difference. The first one is marginal annual growth. It is defined how much volume the forest is accumulating in one given year. Suppose the forest starts the year with 200 cubic feet of timber and ends the year with 300 cubic feet. Then the marginal growth for this forest is 100 cubic feet. And the second concept is mean annual increment, which is defined as the average volume gain over the lifetime of a forest. So we can also understand the mean annual increment from another perspective. It is the volume of tree at age t divided by the number of years. So we can use this equation to define mean annual increment. And for example, if a 5-year-old forest has 200 cubic feet of timber, then the mean annual increment is 200 over 5, which is equal to 40 cubic feet per year. So remember, from biological management's perspective, we want to maximize average annual growth, which is also our mean annual increment. When maximizing mean annual increment, we maximize the volume of wood produced over time. So from this table, we can see the mean average increment is maximized at year 5. And to better understand this question, I will start to explain the first row of this table. So in year 0, the volume of timber is 0. So that also means the mean annual increment is also 0. However, tree starts to grow in the first year, right? That means the marginal growth at year 0 is 80. So from this case, the marginal growth of this tree at year 0 is 80. And in year 1, the timber volume becomes 80 due to our marginal growth, and then our mean annual increment is also 80, because 80 over 1 is 80, right? And remember, we talked before, for small tree, for young tree, the growth rate is very low, and for medium-aged tree, the growth rate increases. For mature tree, the growth rate reverses. So come back to this table. From year 1, the marginal growth for year 1 would be greater than the marginal growth for year 0. Why? Because the size of the tree becomes larger, so they grow faster than 1 year before. So in year 1, the marginal growth is equal to 120. Then the total volume due to year 0 and year 1 would be 200. The mean annual increment would be 200 over 2, because there are 2 years, right? So 200 over 2 is 100. The marginal growth rate in year 2 again is greater than the marginal growth in year 1, which is 200. Then the total volume in year 3 would be 200 plus 200 would be equal to 400. The mean annual increment would be equal to 400 divided by 3 and 133. The marginal growth in year 3 is greater than year 2. And we repeat the process until the tree is getting mature. Then the marginal growth would become 0 again. So here it is. So as we can say, from biological management's perspective, we want to maximize the mean annual increment, which is here 276. And remember how we get mean annual increment. We get mean annual increment by dividing the timber volume by the year. So the 276 is depending on the volume in year 5. That is what I mean. In in this case, the maximized average annual growth happens around year 5. And that is biological management's objective. However, that is not an efficient level allocation. So remember how we defined the efficient level of allocation. At that specific level, our net benefit is maximized. So in this case, even though the mean annual increment is maximized, the net benefit may not be maximized at this level. So in other words, I can say maybe this level is not an efficient allocation from economic definition. So let's restart to do decision from economic perspective. Suppose we start with a clear field with nothing planted, and our objective is to determine what the optimal rotation length should be. The rotation length will occur when the present value of net benefits is maximized. And when the present value of net benefits is maximized, then we call this level is an efficient level. Benefits are measured using the potential volume of wood given the growth rate and the price of the lumber. The annual incremental growth represents the marginal growth. Planting costs are immediate and thus are not discounted, while the harvesting costs are discounted because they paid in the future and are proportional to the amount of timber harvested. So, according to that, our net benefits are calculated by subtracting the present value of costs from the value of the timber at harvest age. The discount rate would affect the harvest decision. High discount rate and high replanting cost could make the replanting extremely expensive. And the question we want to answer from economic definition is that when should we harvest this forest stand to maximize the present value of the net benefit? And here are several assumptions we need to make before we jump to answer this question. First, the price of timber per cubic meter is constant, and the marginal costs of harvesting per cubic meter is also constant. There is a fixed cost of planting the forest, which happens at time 0. So we start from the single rotation model. We need to find the optimal time that will maximize the present value of that benefit. So first we need to find the present value of benefits and then present value of costs. The present value of net benefits would be the difference of those two terms, right? So the present value of benefits can be calculated by using price and forest volume, and also we need to discount this value because this happens in the future. So this equation expresses the present value of benefits. Then the present value of costs. There are two types of costs. The first one is the fixed cost, which happens in time 0. It is just our planting cost. And the second one is the harvest cost, which happens in the future. So that means we need to convert the future value of harvest cost back to present value of harvest cost. So that is the equation we can use to convert the future value back to the present value. And C is just our marginal cost of harvest. QT is just the volume of forest at time t. Then the present value of net benefits is equal to the difference between the present value of benefits and the present value of costs. So we need to find a time t that maximizes the difference between those two terms. So that is all we need to know about the single rotation model. To solve this equation is too complicated for this course, but at least you need to understand the basic logic to get this equation. And from our perspective, from economic perspective, our goal is to maximize the present value of net benefits. And here I have a question: holding all else equal, if the discount rate increases, then the optimal rotation length will increase, decrease, or stay the same. And the optimal rotation length, the rotation length is defined as how long to let the tree grow. So the correct answer is that the optimal rotation length will decrease, because when the discount rate increases, that means the replanting cost for next rotation, for next period, would also increase, right? So we want to replant as soon as possible. So if we want to replant the next generation as soon as possible, that means the rotation length for current generation would decrease. And the next topic is the infinite planning. The infinite planning model is different from the single harvest model because it recognizes the interdependence between periods. What does that mean? That means my decision to delay harvests impose costs on the next harvest periods. Or we can say it is a dynamic problem. My action in this period would affect my action in the next period, and I need to find the optimal option to maximize my net benefit. I hope you can still remember the logic to solve the dynamic problem. And for this case, the opportunity cost of delaying the next rotation must be outweighed by the gain in the tree growth. And all else being equal, the optimal rotation length in the infinite model would be shorter than the single harvest case, because we need to think about the opportunity cost of starting the next cycle later. And here is a graph for the infinite model. So as we can see, each curve represents a rotation length, and the rotation length is equal to 50 years, which is much less or much shorter than the rotation length in a single tree model. So that is the infinite model. And always remember, in economics, we maximize net present benefits rather than the total volume of forest. And here are some externalities in forestry that lead to market inefficiency. And remember how we discussed the externality in market efficiency topic. When there is externalities and when we didn't take those externalities into consideration, then our market equilibrium may be inefficient. So that also applies to forestry. When there are those externalities, and when we didn't take those factors into consideration to make decision about like when to harvest, how much to harvest, then our decision may be inefficient. So the first one is ecosystem service. Our ecosystem services may be lost when forests are harvested, and then there may be loss of biodiversity, which is very easy to understand, right? Also, the harvest of forest may lead to climate change, and how we value that, how we measure the climate change. Also, some forest lands are just reserved for agriculture. So if those lands are just harvested, how about our agriculture? So it is hard for us to take all those factors into consideration, and there would even be more externalities, more effects of harvest we need to take into consideration to make the efficient decision. That is what I mean. Externalities may lead to market inefficiency. Then I will talk about the problems with some policies. For example, government resettlement programs. These programs have encouraged deforestation by facilitating the movement of migrants into agriculture. So if we can't take those programs into consideration, then our decision may be inefficient. Also, we also need to think about concession agreements that are another source of inefficiency. Concession agreements define the terms under which public forests can be harvested. So when we need to make a decision about how to harvest, when to harvest, and how much to harvest, we need to take all those factors as much as we can. Also, there is a positive relationship between poverty and deforestation. In some developing countries, they even encourage deforestation to raise money to pay off their debt. So that is what I mean, a relationship between poverty and deforestation. Because of poverty, they need to cut off their trees to pay off their debt, but also because of their debt, they don't have so many funding to replant new forest. That is the relationship between poverty and deforestation. And here are some ways we can encourage people, especially people in developing countries, to replant their forest. For example, the first method is called debt for natural swaps. That is, the non-governmental organization would buy the developing country's debt, typically at a discount if the repayment by the developing country is unlikely, is impossible. Then the non-governmental organization would trade the debt back to the developing country in exchange for environmental action such as protection of tropical forest, and in that way they can protect the forest. Another method, like extractive reserve, that is defined as the areas reserved for indigenous people to engage in traditional hunting and gathering activities. And that also means we need to protect those types of areas for indigenous people. And if there were forest, we have to protect the forest. And here is an example that for natural method. You can click the link for more details. And there is also a global effort to protect our forest. There is a fund called the World Heritage Fund, and the fund is used to protect culture and natural environments of outstanding universal value like our forest. And also some people encourage we make a payment for ecosystem service in order to reduce emissions through deforestation and forest degradation. And there is one payment for ecosystem called the royalty payment. It grants payments to biologically rich countries, and mostly those countries are developing countries, for all products developed from species in those countries. And those are the royalties are incentives for those countries to preserve their biological diversity, to preserve their forest, and in this way we can also protect our environment to reduce our emission. And that's all for this video.